Hello guys, in this video we'll be learning about identification and correction of the glitches in your output waveform. First, what is a glitch? A glitch is a transition that occurs on a signal before the signal settles to its intended value. Let us see the waveform. This is the waveform where you can see that there is a glitch in the output waveform here and here due to Q. Do we always use the simplest possible equation as the template for our circuit? Yes, because it minimizes the circuit cost and maximizes the performance. Let us look into an example where you can identify the glitch and also correct them. This is the expression we solved in the last video where we reduced it to C bar A plus CB. Now the circuit diagram for this expression will be this using logical gates. Now, if this is the circuit diagram, when A is 1, B is 1 and C makes a transition from 1 to 0. Before the transition C is 1, the output 1 is due to the down AND gate. After the C transition or after C changes from 1 to 0, the bottom AND gate turns off and the top AND gate turns on. Eventually the Y output becomes 1 again, but the turning on of the top AND gate is delayed by the TPD of your inverter. It's delayed by your propagation delay of the inverter. So there's a brief small period of time where neither AND gate is on. Both the AND gates are off. So for a small moment, the output becomes 0. You can see the output 0 here. The short blip in Y's value is called a glitch. It may result for a small period of time. This is the glitch and it may result for a small period of time. It would be good to avoid glitches. Now, how to remove glitches? To avoid glitches, we go back to the truth table. We search the truth table for don't care situations. For example, look at the first and third rows of the original truth table on the left. In both cases, A is 0, C is 0, so Y is 0. The only difference is the value of B. So we put don't care term in place of B. You can see that in the first and third case, A and C is 0, the output Y is 0. B is changing, so the output is not dependent on B. Same way, second and fourth case, C is 0, A is 1, B is again changing and Y is 1. So we put a don't care for B again. Same way, fifth and sixth terms. Now C is 1, B is 0, A is changing. So we put a don't care term for A. The output remains same. You can see that. The last two terms, C is 1, B is 1, A is changing, but the output is not changing. So your output is not dependent on A. So we put a don't care term for A. Now when you see the first 0, 0, 0 term and 1, 0, 0 term, the output is 0 and 0. C is changing, but B and A is same. So we put a don't care term for C. The last term 1, 1, 1 and 0, 1, 1. In both cases A is 1. In both cases the output is 1. A is 1 and B is 1. Only C is changing. So we put a don't care term for C. So what are the observations you make from this truth table changing method? Now the simplified expression will be AC bar plus BC plus AB. So this is your new circuit diagram and this is your new waveform. So now if A and B are both high, output Y will be 1 independent of C value. So the 1 to 0 transition on the C input does not cause a glitch on the Y output. You can see that there are no glitches on the Y output just by introducing another AND gate. Thank you.